Hi everyone. Today we're going to see an example of some of the steps in the visual phasing process, namely assigning recombination points and then solving for the chromosome to the grandparent level and then using cousin matches to properly assign to specific grandparents. And the goal here again is to use three or more siblings compared to each other and then to cousins to be able to solve for where they inherited their DNA from to the grandparent level. So we're going to discuss this with a live example with chromosome 17, where I had three Lehmann brothers, R, D, and L. They all tested and took DNA tests, and so we could do this visual phasing process. They had their tests uploaded to GEDmatch, and then using this visual phasing spreadsheet, I was able to pull that data into the spreadsheet across each of the chromosomes, comparing each of the brothers to themselves, to each of the other brothers. So you have here on this line R and D compared to each other. The second line is R and L, so looking at the DNA across chromosome 17 that R and L share, and then finally D and L. So you have three different types of connections based off of three siblings. And so what I have already done is assigned the places where the recombination points are. So where do we find those again? We're looking for change in colors here. So you can see over here, and you want to see it across two different areas, two different of these met lines. So we see here that R and D go from this green state where they're sharing both sets of grandparents to sharing one. And over here, where D and L are sharing one set of grandparents and then they're sharing zero. So there's a change here, and so I assigned a recombination point. There's clearly a recombination point. And I went through the rest of the chromosome 17, and assigned them. So now we have to assign who owns the recombination point. And we're going to put a letter designating the owner, because that will help us with solving the chromosome. So if we start with this example here, where R and D, they are fully sharing a grandparent, and then they are only sharing one of the grandparents. And then D and L go from 1 to 0. We can see that who is the common brother, who is the common letter between this line and this line. You have R and D and L. Well, we know that D is going to own this recombination point because it's for both of these. We see D changing states. It's over here where D is changing his grandparent. Let's move on to the next one over here. Here we can see that R and L see a change where it's mostly yellow to it's fully green here. So they're going from one grandparent shared to both sets of grandparents shared across this segment of DNA. And then likewise, you have D and L go from no sharing to one sharing. So if you look at the combination between R and L and D and L, we can see that it's L who owns this recombination point. We go to the third one here. And here we can see the change in state goes for both R and D, where it goes from blue to black, and for R and L, where it goes from all green to the yellow. So we can say here, since R and D and R and L see a change in state right here, it is R that owns this recombination point. Going further along here, and we can see another change in state between R and D, where it goes from black to blue, and then over here between D and L, where it goes from the blue to the black. And so again, looking at the common person who is involved in both of these changes, this would be D. D owns this recombination point. And then finally, this is the last recombination point along this chromosome. We can see that R and D see a change in state from this yellow to all green, which means that they go from sharing one set of grandparents to sharing both sets. And we have R and L see a change, right, where they are sharing one grandparent to going to none. So we can assign this one to R because R sees a change compared to both brothers. So it's R who's changing grandparents along this segment. So that's the first step, is assigning the recombination points. It's very important. Sometimes it can be a little challenging to figure out exactly where the recombination points are. In this example, on chromosome 17, it is relatively straightforward, which made our job a little bit easier. Now let's go to the second stage, which is to assign, to solve the chromosome to the grandparent level. And I'm going to be doing this live. Hopefully, it goes pretty smoothly. So what you want to do is start with a section of the chromosome where there is a chain, either an area where it's black or an area where it's fully green. And I think we should start off maybe on the far right end of the chromosome. We see a big black section here between D and L, and we have a big green section between R and D. So what we'll start here is you start anywhere where you have either a green section or a black section, and you assign it to a grandparent. And so we don't know if they're paternal grandparents, we don't know if they're maternal grandparents, but there's one set that's G1 and G2, and another set for the other parent, which is other side, which will be G3 or G4. So we just start by assigning G1 in this little cell here, and G3 to this cell here. So we can say that R inherited this segment from R1, from G1 and G3. Now we know that R and D share the same sets of grandparents. It's a fully green section between R and D. So we can know that G1 and G3 also go right here. And what's nice is that this will now fill in all sections that G1 and G3 until there is a recombination point for D. So you can see it filled in a bigger section for G1 and G3. And we know that D and L, they do not share anything on this section, and only share partial here, but also don't share anything here. So because it's completely black here, we assign the opposite grandparents, G2 and G4, to this set for L. And you can see it filled up an even bigger section because there is no recombination point until right here. All right, so we've already solved for a good amount based off of that. What we can see also here, again, we're going to try and look for other areas where there's green or black to try and solve for specific grandparents. So, and again, I'm doing this live. We can see that R and L share a section right here, which means where L is G2 and G4, R must also be G2 and G4. So we're going to put both of those in there. Okay, so now we've solved this part of the chromosome because using this green section that helped us solve for the first part of this chromosome for Richard, denoted with the letter R. All right, so now we can look at this section here that where R and D are sharing completely. That's fully green. So if R is G2 and G4, D should also be G2 and G4. So let's put those in and see what we've got. Okay. So at this point, I believe I have been able to solve everything that I can without making any further assumptions. Now, what we will do now is an important step that happens in the building of the chromosome, and that is assigning. We are going to make an implicit assumption about either the top row or the bottom row being, the paternal line or the maternal line. And you can only do this once on the chromosome. And I like to do it on a section where we have pretty good coverage. So I think it probably makes the most sense to do this in the middle here. And so what we see here is that G2 and G4 are R has G2 and G4 as the grandparents that he's inherited for this part of the DNA. And then there's a recombination point for R. We are now going to make an assumption about where or about what happens here. And what we'll do is assign this to, we're going to make one of these change states. You can't change both of them. Only one of these will change. And so what we'll do here is assign, have this change from G4 to G3, but keep G2 the same. So I'm going to do that. So we're making, again, at a recombination point, only one set of grandparents change. We made the assumption that this is going to be G2 and G3. Okay. Now, based off of that, we can see that R and D do not share any DNA here. So that would mean that this has to be G1 and G1, the opposite of R, G1 and G4. And what's nice here is that this will now solve the remainder of the chromosome for D. And we can use this, okay, to then look at D and L on this section, G1 and G4. D and L do not share either any of the same ones, so we can assign this to G2 and G3. Sorry, G2 and G3. So this has now completed the full chromosome. Now we had to make one assumption about the grandparent level. You can only do that once, but that was enough to solve everything to the grandparent level. So once we do that, what we'll do is we're going to merge all of these together. So it looks like a nice little representation here of a map. Okay. So what we're going to do here is now use cousin matches to assign these G1, G2s, G3s, and G4s to specific grandparents. And we're going to use cousins for that. So we're now going to use cousin matches again to assign these letters. Now I know already that I have properly assigned the G1 and G2 to be the paternal grandparents and G3 and G4 to be maternal grandparents. Sometimes it's not clear whether that might have to be switched. If you need to switch them through cousin matches, what you'll do is you'll go to this taskbar and you'll do flip, and that will flip the grandparents to the right station. But as we have it here and how I built it, G1 and G2 are going to be the paternal grandparents, and G3 and G4 are going to be the maternal. All right, so let's go first look at a maternal cousin and see how she compares. Oh, maybe before I do that, it's important to see this completed chromosome map. You can see the segment map, and you can see if this picture compares with what we see here. So that would be the greens, the yellows, and the reds. The reds are symbol of the blacks. You can see that these map perfectly with what the chromosome looks like visually. Okay, now let's go to the cousins. And let's start with a maternal cousin named Tessa. She's a fourth cousin of these brothers. And it takes a little bit of time to load her data. So she also had uploaded her data to GEDmatch, and I had incorporated it into this Excel file. Now you don't necessarily need that to be able to do this analysis. You can look at other browsers like chromosome browsers on MyHeritage or Family Tree DNA and sort of map it visually in your mind to this map that you've already built out. But it's helpful to also have it in GEDmatch, which you can then pull into this Excel file. So for in this case, this cousin did do that, and so it's easier to visualize. So this is a maternal relative. I've already determined that G3 and G4 are in fact maternal. And so what we're going to do is we can see where Tessa shares DNA with the three brothers along chromosome 17. Let's just take a look here. You can see that she shares DNA with two of the three brothers. She shares at the end of the chromosome with both R and D, and she shares them at the end of the chromosome. Okay, so what we can do is, I know that she is a cousin through their maternal grandfather. And his surname was Lichtenberg. And so we can see here that G3, which is the maternal grandparent, she shares DNA with both Richard and David because they both must have inherited the Lichtenberg DNA. The purple here must be connected to the grandparent Lichtenberg. And conversely, Len, denoted by the letter L, he did not share any DNA with Tessa along this whole chromosome, and it must mean that he must have inherited his maternal DNA along from this area from the other grandparent, in this case, a grandparent with the surname Stein, the maternal grandmother. So what we're going to do is we're going to reassign G3 and G4 to these grandparents. So what's amazing is, even though we only know this small section, and again, it's still pretty sizable, it's 30 centimorgans, this is a real significant segment, even though we only know that those two segments were inherited by the Lichtenberg, from the Lichtenberg side, since we have solved this chromosome map across the entire chromosome, assigning it to grandparents, we can assign all G3s to Lichtenberg, to the maternal grandfather, and we can assign all G4s to Stein, the maternal grandmother. So let's see how we do that. We'll replace G3, and we'll do that with Lichtenberg. We'll have it run through, and look, it all changed. All those segments have now been assigned to the correct grandparent. We're going to do the same thing with G4 and do it to Stein, who's the maternal grandmother. All right, so that's pretty nice. We've already solved the entire chromosome 17 for the maternal grandparent. Now we're going to do something very similar on the paternal side. We're going to take this cousin here named Dave. He also shares DNA with the brothers on chromosome 17. We'll wait as this loads. Okay, and so what we're seeing here is how Dave shares DNA with the brothers, and he is a paternal cousin. He's a fourth cousin once removed along the paternal line. So this is going to help solve the paternal grandparents along this chromosome. And even though the start points differ a little slightly, they all end around the same area. This is clearly all the same segment. And it's about 10 centimorgans, which is not as big as the one that Tessa shared, but it is still significant enough. And it's shared by all three brothers, right? All three brothers have this blue, indicating that they share DNA with Dave in this section of the chromosome. Now, I know that we can see here that actually that makes sense. All of them along this segment here are part of G2. So they all share the same grandparent along this segment. We would expect that if Dave would share DNA with R, he would also share DNA with D and L here as well, and we see that. So how is Dave related to the three brothers? Well, he is related in a few different ways, but they're all through one grandparent, and that is the paternal grandmother, whose last name was Landau. So we now know that G2 can be assigned to Landau, and G1 can be assigned to the paternal grandfather, which is Lehmann. So let's go and do that. Let's assign G2 to Landau. And let's do G1 to Lehmann. And voila, you have now solved the entire chromosome to the grandparent level. Now, I can be pretty confident about this because I also have other cousins that have matched along this chromosome that weren't on GEDmatch. I only featured one here from one maternal side, one paternal side, but I've had additional cousins tests that have bolstered these findings, that have shown from, cousins from the Stein side, cousins from the Lehmann side that have shared DNA along chromosome 17 that give us high confidence that this is the correct map. What you'll do once you have it all mapped out, and these, what you'll do is you'll copy these segments, and sometimes you might have to go into GEDmatch to get defined endpoints, but in this case, for most of this, you won't need to do that, and you would copy the segment lengths into DNA Painter, and you can now paint each of the brothers' chromosome maps for chromosome 17, solving to their grandparent level. And that's it for this video.